Hello, my name's Andy Jeffrey. I'm president of Figulo, and I founded Figulo just over 2 years ago. We are revolutionising 30,000 years of ceramic production, and just to set the stage, sort of imagine walking along the beach and finding this piece of driftwood and saying, I really like that pattern, I want that in ceramic. Well, I haven't been to the beach lately, but I was having breakfast the other day and I was making my toast, and I thought, wow, that would look really good in ceramic too. So we were able to scan that piece of toast and turn that into a ceramic object, you know, in just a couple of steps, print it, glaze it, and we had something that was very unique. Again, to set the stage, we can take an image like this cracked glass, then apply that image to a normal object like a ceramic cup, and create something that's unique and at the same time beautiful. We did this with this wood pattern as well. We took a photograph of the wood, took that image and then applied it to this object and then 3D printed that in ceramic. That just sort of sets the stage for what the things that we can do at Figulo and the types of things that we can make in ceramic. Ceramics are really old. These are some of the oldest objects I was able to find on the web, and you know, this figurine is, you know, dated to 29,000 BC, which is, you know, pretty ancient, and the pottery vase is, you know, 10,000 BC. So we're taking this, you know, very ancient art form and we're sort of transforming it in the 21st century. Pottery wheels have been around forever. People make molds and, you know, make ceramics that way. We interact with ceramics every day. They're ubiquitous in our lives. And, you know, we're turning that on its head by using 3D printers. And we currently run 6 3D printers. We make ceramics using them. This was Figulo object number 1, and this was one of the things that convinced me that I could actually print ceramics. I downloaded this cup design from, you know, off the web. We printed it, I fired it, and then I glazed it. And glazing was the real, I guess, really the thing that convinced me that we could make decorative objects. Until then, we couldn't work out how to glaze the ceramic that we produced in the 3D printers. And once we got to this stage, that convinced me we could do this as a business, and I literally started the company. Just to give you a little bit of historical perspective, I've been working on 3D printing of ceramics since the mid-90s, and I was one of the first, my first company was one of the first licensees of the MIT 3D printing process, which is the powder-based process and using an inkjet printer to selectively join the powder together. This was the first machine that I bought, and it was made by Sologen Technologies. They were also one of the, I think, the first licensee of 3D printing from MIT. We were trying to jet, on that machine has silicon carbide powder in it. We were trying to jet colloidal silica. It proved extremely difficult to do. We struggled with it for 6 years trying to get the technology to work. We made some pretty interesting objects, and we were focused on technical ceramics at that time. We were making filters for hot gas filtration. These filters were being used in coal-burning power plants, and the image on the left is one of our first prototype filters going into a pilot plant, and the other images are you know, objects, different filter objects that we made. The real advantage that I saw then was that we could, and it still exists, was that complexity was free. We could make these objects in any shape, design anything we wanted and build it. We didn't have to think how we were going to make this object. It was just something that we're able to do, and I still don't, you know, making things isn't a question for me at all. If someone gives me a design, I almost always know that we can make it. It's just a question, okay, what are we going to charge for it? How much is it going to cost? Our process is pretty simple. We need to have content, and content is still one of the challenges of our industry, getting enough content that we can make. And you know, there are more and more content creation applications, software, you know, photographic techniques that are coming along. Once we get that content, we then just download that to one of our 3D printers. We, you know, assemble a build. We just build the objects in ceramic. Those green ceramic objects we then put into a kiln. We fire them. We then have a glazing step, and then we end up with a finished, durable, usable ceramic object. So this is a ceramic object that'll, you know, stand the test of time and hopefully be around in 30,000 years when someone's excavating Boston or wherever our ceramics end up. Again, we use Z printers, a process which I'm sure everyone is familiar with here. We use our own proprietary powder. We have that made to our specific recipe. We use our own proprietary binders, which we jet through the print heads. This is an example of a typical build out of one of our machines. Those pieces are green and they've just been depowdered. We can, you know, produce a variety of shapes, you know, just very, very easily. And many of these objects can't be made any other way. The ceramic pieces then go into our kilns, and this is an image of the ceramics sitting in our kiln, ready to be fired. It's again, once the objects have been printed, it starts to become a fairly straightforward ceramic process. So once they go into the kiln, we fire those. They come out of the kiln, they go into a glazing process, and it's pretty much like any other ceramic operation you might see anywhere else in the world. This gives you an example of the sort of the detail we can get in our bisque fired. That's our first fired pieces, and this piece was about 4 inches high. You can see there's some very, you know, some very nice detail and surface structure in that piece. The lower section of that piece actually has a free floating ceramic ball which is sitting inside the sort of the spherical shape at the bottom. So there's a couple of pieces inside that piece, and again, this is something which would be extremely difficult to make in any other process. This is an example of, or these are our kilns that we use for firing the pieces. So fairly standard pottery kilns. We have 3 of them, and we run these 7 days a week. You know, they're usually operating you know, 20 hours a day over that time period. We glaze the pieces in a very conventional way, just by dipping the pieces into the glaze. And this is an example of a weave cup, which is, there's one on display out at the front of the exhibit here. And we make many of these, and it's, again, we develop all our own colours. The glazes are something we develop to match our bisque pieces, and we end up with some very, very beautiful objects. This is our current colour palette. So we have a set of colours that we offer to most of the companies we supply to. We also do custom glazes as well. So with particular artists, we've developed individual glazes which we will work with the artist to match particular aesthetic requirements that they might have. And we've, with one artist, we have a really nice celadon glaze which is currently on some pieces which are on display in China at the moment. Again, to emphasize the real power of 3D printing is really this complexity issue, and the complexity really is free. We don't have to think about how we're going to make that lattice bowl. We just upload that file to the machine and we just turn the machine on. All of the, you know, we can work with artists to put the artist can put a huge amount of time into developing their design without having to worry about how they're going to make it or execute that design. And the investment in design can be really stunning, and it can pay off for the artist as well. This is another example of sort of reimagining an old object, and we worked with Michael Eden, who's a well-known UK artist here, and he took the Portland vase, which is a famous ancient object that was found here in England, and then he reimagined that, and we printed that in ceramic, and you know, completely sort of redefined the aesthetics of this piece using a modern technology. We've worked with another company, Emerging Objects, and Ronald Rail is one of the, I think, for my mind, one of the leading designers using 3D printing to create his work, and he's creating a number of the seat slug, which is the image on the left, is actually a functional piece of 3D printed art, and it's durable. You can jump on it, you can sit on it, and every single piece of that seat is individually designed. It's a unique piece. The whole thing fits together, and it's an example of this technology creating something that's beautiful, functional, and can be used in a public setting. This is another object that we did for Emerging Objects. It was a concept of how we could make bricks that would enable you to put plants in them and you know, stack them up, and we could essentially create a green wall using an object that we could make using 3D printing. These are again the lattice bowl is another object that we've collaborated with Emerging Objects with. The vases on the left were some objects that we downloaded from the Cubify site, and we enlarged them and 3D printed those in ceramic, and there's one of them actually on display at the 3D Systems booth. But again, we can take any design, we can put it into our machines and make a beautiful object that is durable and functional at the same time. Just to talk a little bit about some of the art commissions we've done, the objects on the top left of this slide were made for a well-known designer here in England, Susan Trockme. We made these pieces, they're called aspirals, and they were exhibited at the New York Contemporary Design and Furniture Fair last year, you know, they were particularly stunning. The bottom left is an artist that we've worked with from Australia called Peter Nilsson, and this is an example of a ceramic piece, one of a whole series that we made, which were exhibited in an exhibition in Australia at the beginning of this year. And the objects on the right are again another set of objects that we made for a New York artist called Christopher Ho. And again, these were in an exhibit in New York that was held earlier this year. One of the things we like about working with artists is they actually really challenge us in terms of technical aspects of the work. The objects are generally the biggest objects that we can physically make in the machine. They're usually, you know, colour is a key component, so we're always looking to make very, very beautiful colours, make the glazes the highest quality that we can. And firing some of these large pieces is extremely difficult, so they constantly pushes us to develop our firing techniques to be able to, you know, build these large pieces, fire them without the pieces slumping, and you know, being able to realise the artist's dream and sort of generate these pieces that they can then exhibit. Sort of some of the consumer stuff we do. Again, we're making some objects for Cubify, and their My Robot Nation division came to us, and we made a set of their little robots in ceramic again, and they look really good. They're beautiful. They're fun. And you know, this is again something that would be extremely difficult to make in you know, using any other technique. This is a creamer or a little jug that we make, and again, this object is really again a beautiful idea, something that can't be made any other way except by 3D printing. It really emphasises the sort of the beauty and the design ingenuity that we can incorporate in our ceramic pieces. This was a really interesting project we did for, he's actually, Craig Kaplan's a university professor in, at the University of Waterloo in Canada. He was trying to explain parabolas to his students, and he came up with this coffee cup, or this espresso cup design called the Rocket Cup. This design went viral on the web, and it became our single biggest selling, or the object that we've made the most of. We must have made hundreds of these little cups. The interesting thing about this was we made so many, the design became so well known that it enabled him to essentially get into bridge manufacturing with us. We enabled him to test the market, get into the market with this object, and he is now having these objects mass produced. You know, he couldn't have done that without 3D printing, and 3D printing in ceramic, because people were actually able to use the cup. They liked the cup, they blogged about the cup, and then you know, he's developed a business with this design, and we're really, you know, that's one of the really pleasing things about Figulo, is we enable people to get into business and have objects that can actually be used and sold and you know, are durable. This is one of the designs I like best, and we've worked with an artist or an engineer, J.F. Brandon in New York, and he again designed this weave cup, which we make many hundreds of. And again, this is a good example of a design that can't be made by conventional methods. It's unique, it's functional. I drink my coffee out of one of these every day, and I encourage all my employees to drink out of our own cups as well. Again, there's an example of one of those at the out at the exhibit at the front of the hall here, and you know, I just enjoy using this object every single day. So to end up, you know, this is the sort of a good example of the objects that we make. So, you know, we go from functional with coffee cups, sort of fun with a little figure. We make lots of little figures. Again, functional and beautiful with the lattice bowl. On the bottom left, that brick is actually an architectural feature. It's something that we want to get into more and more, is doing more architectural work, and we're working on using a bigger build platform to be able to make bigger parts. Eventually, we'd like to make, you know, I'd like to be able to 3D print a whole bathroom, and you know, every ceramic object, including the tiles, we'd like to have made using 3D printing, and a couple of fun little bunnies that. Again, were one of the earliest objects that we made, and they continue to be very popular through one of our partners. Thank you, and I've got a few minutes left, and I'd be very happy to take questions.
What is your biggest build area at the moment?
We're using Z510, so we can 340 millimeters by 240 by 200. But one of the things we can do, our material is, it has some fairly unique properties in that if we can make assemblies and fire the pieces together. So Our real technical limitation in size is the size of our kilns. So that's the really limits the size of the object that we can physically make, is how big we can fire. Our biggest kiln is about it's about half a cubic metre in size, and we can. I think the tallest we can go to is about 750 millimetres.
You did mention colloidal materials and your experience in that. Could you enlarge on that, please? We tried to jet colloidal silica using a Cytex printhead way back, and the problem with the colloidal materials was they basically wore out the printhead very quickly. So we were using a continuous jet printhead, so every jet was jetting all the time, and the way we deflected the jets to stop them hitting the bed. And I don't know if anyone's familiar with continuous jet printheads, but we were charging the drops and deflecting the drops within about half a millimetre. So we had to charge and deflect. If the drop got out of shape at all, if it wasn't quite round enough, we either didn't deflect it, or we deflected it when we didn't want to deflect it. And so we would end up with a missing jet, or a jet that was jetting when we didn't want it to jet. And with printing of ceramic, one jet that's not working really creates a huge problem. So it was, and the reason the jets got out of shape was the colloidal silica just wore away the orifice plate in the printhead. And so that was, it made the process very unreliable. And once we wore out the printhead, it was, I think, $2,500 to replace that printhead, just because one jet wasn't working. So it wasn't a commercial success, put it that way.
How long would it take to produce, to print one cup? And would you do multiples at a time, or do you do one?
The printing in our process is actually the least time-consuming part of the process. Firing takes much longer than printing, so we print at around 20 millimetres per hour, so it's fairly fast. That we can, we tend to use different strategies to print. With all of these 3D printing machines, or at least the Z Corp, we've got 3 axes. A fast axis which runs at about 1 metre a second, the slow axis which is about 1 metre a minute, and the Z axis which is about 1 metre per day. So when we print, we try to use the fast axis as much as possible. And and for manufacturing, when we think about making a lot of stuff, we think, okay, how can we have a machine which has the biggest fast axis we can, and how do we use that the most? So when we assemble our builds, those are the sorts of strategies that we look to when we're putting things together. And there are also other sort of economies that we look at as well. I mean, if we can increase our layer thickness without sacrificing too much detail, say we go from 100 microns to 110 microns, we've immediately, knocked out 10% of the layers that we have to build, and that's a corresponding increase in utilisation of the machine and our building efficiency. So we look at a whole range of different things to try and optimise and make as much stuff as quickly as possible with the platforms that we have.
The comment I have to make is following up from the gentleman asking about the build envelope. Do you see any time soon where you might be making sanitary ware? And about the problem about kiln size, you could quite easily upsize kilns, I'm sure you know.
Yeah.
Yeah.
Yes, I mean, we've already looked at that, and one of the interesting things with most ceramic objects that you buy, sanitary ware and all that sort of stuff is designed because it has to be moulded, and it has it has a lot of, you know, the designs are, you know, I guess limited because they do have to be moulded. Well, we can separate. The interesting thing with 3D printing is we can separate sort of functional and non-functional aspects of the design. So we can make an object which, you know, is sort of freed up from the constraint of the mould. We can make it sort of so it looks a lot better. We can sort of have function, you know, where it needs to be strong, we can make it strong. Where it needs to be beautiful, we can make it beautiful, and we can, you know, in a sort of, to get a little bit technical, in a toilet, one of the biggest areas where they have scrap is the actual the pipe that goes to the sewer. Is sort of that piece of it can distort, and you know, you get non-optimum flow through that little S-bend. Well, with 3D printing, you don't actually, you never have that. Everything is made according to the drawing every single time, and so it really has some benefits in terms of you know, optimizing the utility and the performance of the object, as well as making it more beautiful and appealing to look at. So there are some, you know, it does offer some great benefits.
You've just mentioned that when you're printing objects, you can print them perfectly. How about when it goes in the kiln? May they distort when you fire them?
Yes, they do. One of the, I guess, the benefits of our powder, or the design characteristics of our powder, when we, the powder was originally developed as a technical ceramic, and one of the things that we tried to do was reduce the shrinkage. So we have, compared to a conventional ceramic, we have very, very low shrinkage. So distortion is minimized because of that. We also have techniques that we can that we use to prevent the distortion happening in the kiln as well. And we can also you know, design you know, for some of our structures we can design, you know, if they're not visible, we can design ceramic lattices inside them, so they have the benefit of structural rigidity and not slumping without adding a lot of weight or material. So we, you know, 3D printing allows us to sort of really look at things from a, you know, just from a design aspect, rather than having to think about manufacturability. We know we can make it. It's just a matter of, you know, how's it going to function as a design.
Do you classify the clay you print? Is that earthenware or stoneware, or is it white clay? Yeah?
It's a material we developed. It's a highly refined aluminosilicate, and it's you know, conventional ceramicists sort of turn up their nose a little bit about it with our material, because it's not really, it's not clay, but it's very clay. It has similar chemistry to clay, but it isn't a clay, and it's not dug up out of the ground. It's refined, and we have it put together to our own specifications.